Introduction to Cloud Spotting. An overview of Mars. Mars is the fourth planet from the Sun. It has a thin atmosphere composed of mainly carbon dioxide, and it possesses geographic features such as the largest volcano, which is Olympus Mons, a canyon system, which is Valles Marineris, craters, and surface ice showcasing its geological history. Zooniverse. As citizen scientists, we contribute to the fundamental understanding of Martian clouds through the classification of distinct cloud shapes, generally cloudy regions, and the identification of cloud arches. The goal of this science project is to explore the planet's climate through the formation of clouds. Purpose. Studies on Mars are crucial for understanding its climate, weather patterns, and potential habitability. Insights gained can inform future missions and the search for past life forms on the planet.
Significance of cloud spotting. Effects on Martian weather. Clouds play a crucial role in Martian weather systems, influencing temperature variations and local weather phenomena. Understanding these effects aids in predicting dust storms and other atmospheric events that impact surface conditions. Implications for climate studies. Studying Martian clouds enhances understanding of seasonal weather changes and atmospheric circulation. This data is pivotal for modeling Martian climate systems and predicting long-term climate trends, directly influencing our comprehension of planetary evolution.
Atmospheric composition of clouds. Martian clouds can be classified into several types: water ice clouds, carbon dioxide clouds, and dust clouds. Each type forms under particular atmospheric conditions and has unique characteristics that impact the Martian environment. Cloud shapes. Currently, scientists recognize 6 distinct cloud shapes: vortex, disk, streak, dotted, gravity waves, and twilight clouds, each identifiable by a particular set of characteristics and the presence of geological features for some of them. Vortex clouds resemble hurricanes on Earth, usually forming near the north and south pole of Mars. Disk clouds, round white features commonly mistaken for surface ice or craters. Streak clouds, which are long, narrow, and generally the same width throughout the shape of the cloud. Dotted clouds, which usually lack structure and direction and are patchy, making them look dotted in appearance. Gravity waves, which are directional and form rows throughout the shape of the cloud that look like waves. And twilight clouds, visible in dark areas where the sun has set on Mars because they are positioned high enough in the atmosphere to reflect light. Arch points. As participants of this project, we were tasked with identifying arch points from images captured. In this specific image, you can see that we identified 8 arch points. Arch points can be described as 2 lines that intersect at the top and have a gap in between them. Humans are better suited to perform this task than computers because different lightings and contrast of the same image can both show and hide various arch points. Cloud spotting examples. From these examples of our different classification activities, which included arch identifications and cloud shape classifications, you can see some arches and cloud shapes are a bit hard to determine as the images are blurry or were only visible with inverted light during the actual activity. Humans are better adapted to identify these arch points and cloud shapes because computers are not as good as identifying features that may look like another feature.
The task of cloud spotting is fairly easy. Once you understand what the task is and how to spot the arch points, it is very straightforward. The task was interesting, however, it was very repetitive. My favorite classifications were the ones where the arch points could only be seen in a specific contrast level. One specific classification had 0 orange points, which confused me on whether I was not looking closely enough or there were really none.
The task for me was fairly easy. Finding the arch peaks and identifying the clouds was not challenging for me. I found this project interesting because beforehand I didn't know about clouds on Mars or even thought about something like that. What I enjoyed the most about this task was identifying the clouds. I found it fun trying to figure out if that specific arch peak was a cloud or if it was just a smudge. One thing I enjoyed the least was creating data tables, which isn't my strong suit. What I found surprising was that the clouds on Mars are seen as arch peaks from the satellite camera.
There were 2 types of classifications: arches and cloud shapes. Of the 2, I think arch identification was a lot easier because you only have to identify one distinct shape, which is an arch. Cloud shape identification was a lot harder because cloud shapes can look like other types of clouds. For example, vortex clouds and disk clouds. Or sometimes you think you're looking at clouds, but it's really light reflection or just a generally cloudy region, which could be very confusing at times. Although arch identification was easier, cloud shape classification was more interesting. To observe the ways clouds could take shape on Mars, how they look similar to the clouds on Earth, and it was surprising to see geological features like volcanoes and surface ice.
What I enjoyed the most, I really enjoyed feeling involved in a meaningful, real-world scientific endeavor. It was interesting to me how we classified the clouds and seeing how my work could potentially contribute to scientific knowledge about Mars's atmosphere. And what I enjoyed the least, to me, the most challenging part was encountering ambiguous or confusing images. Sometimes the cloud formations were hard to distinguish from the surrounding terrain or dust, which made it difficult to confidently classify them. The impact we made. Each of our involvement as citizen scientists with the classifying of cloud types and identifying arc points contributed to the accumulation of a database that scientific researchers can use now and in the future to better understand Mars's atmosphere. This data will help scientists as they now have a reference point for the occurrence of certain cloud types on Mars when they appear, if during a particular season or climate, and how the Martian clouds formations mirror that of Earth's clouds.